Geothermal energy by Celine Phan. Geothermal energy is heat energy that comes from the natural radioactive decay of elements deep within the Earth. Basically, it's your geysers or hot springs. The main goal of geothermal energy is to obtain clean, renewable energy from natural geothermal sources. How does geothermal energy make a difference? Geothermal energy emits no greenhouse gases, burns no fossil fuels, and is extremely efficient. A geothermal system is 3 to 4 times more efficient than the most efficient ordinary system. Because geothermal systems do not burn fossil fuels to make heat, they provide 3 to 4 units of energy for every 1 unit used to power the system. A fossil fuel furnace may be between 78 to 90% efficient, but geothermal energy in comparison is 400% efficient. How does geothermal energy function? Geothermal energy functions very similar to a regular thermal power plant, except the steam to run the turbine comes from water evaporated by Earth's internal heat instead of by burning fossil fuels. So you can see in the dry steam power plant picture, the arrow coming up from the bottom is showing the steam coming up, and then it goes in, it turns the turbine, and then it powers the electrical lines. And then after the steam is used for the turbine, most systems have it to where it goes back down through this other tube, as you can see down here. Additionally, ground source heat pumps, often informally referred to as geothermal heat pumps, use energy from the sun to heat and cool homes. In winter, fluids circulating through the system's loop absorbs stored heat in the ground and carries it indoors. So as you can see here, it would be going through here, all the way through the system, and then back into the house. And then on the inside, there's an indoor unit that compresses the heat to a higher temperature and distributes it throughout the building. In summer, the system reverses and it pulls heat from the building and carries it through the earth loop and depositing it into the cooler earth. So it would go through the house and then down this red right here, through the earth. And then it would carry it through the earth loop, deposit into cooler earth. They can be installed anywhere in the world, and they use 30 to 70% less energy than a standard furnace or air conditioner. Obstacles. While geothermal energy is extremely efficient, there are some obstacles to widespread use. Although the technology is extremely advanced, in order to harvest the energy, sufficient amounts of hot groundwater must be available. But over long periods of time, harvesting groundwater may deplete the source to the point where it is no longer usable. Additionally, we are using our groundwater sources right now. As we can tell, not all places are using it in a sustainable way. And so this fact, along with the fact that we need a lot to actually run the geothermal power plants, it's just those factors working together aren't the best combination. Returning the water to the ground is a way to do it more efficiently and more sustainably. However, not all plants do that, and then it's also the factor we already mentioned before with like outwards pollution and just overuse in general. Additionally, while geothermal plants are inexpensive to run, they are very costly to build. Electricity prices would need to increase by about 25% or more in order to make geothermal energy a financially viable technology. On the environmental impact side, toxic gases and minerals are occasionally encountered as operators go deeper in search of more productive and sustainable reservoirs. However, current recovery methods have proven to be extremely effective, as have scrubbing techniques that protect the air from emissions such as hydrogen sulfide gas. Another unintended consequence is induced seismicity, which just means it can cause earthquakes. Geothermal power plant wells that were drilled below Basel, Switzerland, caused over 10,000 small tremors, which is less than 3.5 on the Richter scale, within just a few days following the start of the hydraulic fracturing process. Whether seismic activity is caused by hydraulic fracturing or whether we are just taking more seismic observations of an earthquake-prone area is not entirely sure, as we haven't gotten that far in the production of geothermal power plants. These are my works consulted, and that is it. Thank you.